Problem number 6, we have a rational function graphed, and we're trying to figure out which of the following functions could have this graph. So the way I approach these kinds of problems, these multiple choice kinds, I don't try to look at the equations first. What I try to do is create my own. So I'm going to create my own based on what I observe. So I notice here that I have -1 is a vertical asymptote, and that translates to a factor of x plus 1 or x minus -1 in the denominator. Vertical asymptote on the graph, x of -1 means an x minus that number, -1, is a factor in the denominator. Then I notice that I have an x-intercept of 2, and an x-intercept of 2 on the graph means that we have a factor of x minus 2 in the numerator. However, I also look at the behavior at that x-intercept. The behavior is it touches the x-axis. Now, touches the x-axis means that my multiplicity of that factor has to be an even number. Right now it's not. So I can make it a 2, I can make it a 4, but I'm just going to start easy and make it a 2. Then I look over at the next feature on my graph, and the next feature is I have a vertical asymptote at x equals 4. That translates to a factor of x minus 4 in the denominator. Now here's the cool part. Notice the behavior near the vertical asymptote has both sides of the vertical asymptote. The graph is moving downwards towards -infinity. That means that the multiplicity of the factor of x minus 4 in the denominator has to be an even number. Odd number, the ends of the graph on each side of the vertical asymptote are at odds with one another. They're not even, they're at odds with one another. One goes down, one goes up. That means that the multiplicity of the factor x plus 1 is an odd number. So I didn't talk about that, but I'm talking about it now. So that would be multiplicity is an odd number, and I would choose 1 as the multiplicity for that one. And then over here, I'm going to choose 2 as the multiplicity of that factor of x minus 4 in the denominator. And then I have another x-intercept here at 6. So an x-intercept of 6 means a factor of x minus 6 in the numerator. And I'm noticing here that it looks like there's a horizontal asymptote at y equals 1. And so that I want to consider as well. And so I want to make sure that my numerator and my denominator have the same degree. So, and that is the case. So I have a 2 and a 1, 1 and a 2. So the numerator and denominator have the same degree. So therefore the end behavior model is y equals 1. And therefore that's the horizontal asymptote. And then I want to make sure that I've got the correct sign. And to have the correct sign, most likely I do, but I just want to check. If I plug in x equals 0, so y at 0, I want to just make sure I get a negative number. I'm not going to be so concerned with what that point is. I just want to make sure it's going to be a negative number. So if I plug in x equals 0, I'm going to get a positive factor for the numerator there. 0 minus 6 is a negative factor. I'm not, like I said, I'm not as concerned about what it is as the sign. If I plug a 0 in for the denominator there, I get a negative. I get a positive. 0 plus 1 is positive. And then 0 minus 4 is negative, but when we square it, it's positive. So both factors in the denominator, when I replace x with 0, are positive. And I have one negative, so therefore that's less than 0. And that checks out. So now I'm just going to look down here. Oh, I wasn't even thinking about that. So now I remember I have these down here. I didn't need to check that, but if there were some minus signs up here, I might have had to do that. So where are we at here? That's it right there. So A is the choice. Just want to double check and make sure. X minus 6, yeah, that's not it. So that's it. So A.